let's do one other way of measuring pH using some other household items. This is red cabbage. It seems purple to me, but stores call it red cabbage. This is also an excellent indicator for acids and bases. The usual green cabbage that we normally use in cooking, that does not work, only this one works. So all we have to do is, I have some pieces of this cabbage cut down. So take them all into a bowl. Here I am using a beaker, but anything is fine. And then pour some really hot water on top of that and let it sit for a little while. If we do that, just the cabbage juice comes into a solution, and that is a really nicely colored purple to deep blue. This is the cabbage juice. Depending on the quality of the cabbage and also how long it was left in hot water, this color changes anywhere from deep blue to like this to pale purple, and then also becomes very, very deep color. So this is the color I got right now. But before we go any further, let's check the pH of this juice. We can always assume that cabbage juice is neutral and go from there. But since I have the pH paper handy, I'm just curious to see what it would be. May not be exactly neutral, but for our purposes it's okay. So all I do is I just dip it in, and then let's check here. It's not exactly neutral, so that's basically 8. It's not 8 either, so maybe more between like 6 and 7. It's not exactly 7 either, because the first one is very purple. It's not so, but it's okay. For all practical purposes, we can just think of this as neutral. So let's take the cabbage juice into these, and then let's add different things. So what do we need for this experiment is mainly cabbage juice, and then however many things you can think of. Okay, so now let's add things. Let's add various things. Let's keep one of them, this one, as cabbage juice, that is neutral. Let me add the acid ones first. So I have some coffee. So if I add some coffee powder to that, let's see the color change. Because it's a solid, it would take. So I hope you can see it turned into like a paler color. And then next I know is a soda. Any soda will do. So let's do this one. As you can see, it turned even darker. And the strongest acid I have handy is lime juice. So let's see what would the pH of this, what would be the color for that one be. That is so drastic change. It's a nice pink. See the gradation. And now let's this is, we're going to keep it as it is. Let's add on the base side, I have some Clorox. Clorox is a milder soap, so it shouldn't make much of a difference, but let's see. Oh wow, that's nice. Nice greenish blue. And I have 2 of them, and I can't decide which one will be stronger, but let's see. I'm adding now ammonia. Ammonia is a household cleaner and much stronger than Clorox. So that turns into a deeper green. And the last one I have is borax powder. Borax is actually the precursor to laundry detergent. So it could be a little bit stronger than ammonia, but let's see. So let me add that. And okay, because it's solid, it's taking a bit of time to dissolve. But no, I thought borax would be stronger than ammonia, but maybe not. Okay, so I would more like, I think it would kind of go like that. So borax would go there, and then it's like that. So how cool is that? We have made kind of like a rainbow of colors with all the available acids and bases. So this is the strongest acid, this is the strongest base. What happens if I add these two together? So technically we know they should come back to neutral. Neutral is that color. So let's see if it comes back to that color or not. So if I add that, that's kind of at that pH. If I add more, there that is. So almost, depending on how much I'm adding. If I add too much of that, this could easily go towards more basic side or more acidic side, which you see we ended up neutralizing that. So that's such a nice rainbow of colors, and we could experiment with different colors.